Alright, simplifying fractions. Well, look at these two shaded regions. In the purple region here, 2 out of the 6 are shaded, and over here only 1 out of the 3 are shaded. But it still takes up the same amount of space, so these are going to be equivalent fractions. So equivalent fractions are fractions with the same value. They mean the same. Well, how do we get equivalent fractions? Well, if we multiply or divide by a fractional form of 1, such as, let's say, 3/3, or maybe 4/4, then we're still going to have an equivalent fraction. So for example, if we said find two equivalent fractions for these two down here, which are 2/6 and 1/3, let's revise that a little bit. We're just finding two equivalent fractions for 2/6. And I'm going to show you how we got 1/3. So with 2/6, if we divide by our common factor, and look at the 2 and 6, 2 will go into both of those. So I'm going to divide the top one by 2 and divide the bottom one by 2. So really I'm dividing by 2 over 2, which is another form of 1. So I get 1/3 when I do that. There's one of my answers. And then I can take the 2/6 and I can multiply it by something, because 2 is my only common factor. But let's say I multiplied it by 3 and 3. So I'm multiplying it by 3/3, which is just another form of 1, because 3 out of 3 is 1 whole. And 2 times 3 is 6, and 3 times 6 is 18. So there I would get 6/18. So those are two equivalent fractions. Again, you can divide by the same factor, or you can multiply by any number. Now what we just did with 2/6 to get 1/3, we divided by the common factor until we couldn't divide by any other common factors. So actually, that's called simplest form. That's when we divide by common factors until no other common factor other than 1 remains. And that's how you know it's reduced all the way. And another way to do that is just to divide by the GCF, the greatest common factor. So for example, if we want to simplify 24 over 32, we can divide by any common factor that we know will go. Like I know that 4 will go, so I can divide them both by 4. And 24 divided by 4 equals 6. 32 divided by 4 is 8. But now if I look at 6/8, there's still a common factor. 2 will still go. So I'm going to divide them both by 2 since they're both even. And 6 divided by 2 is 3. And half of 8 is 4. So 3/4 is the simplest form because I don't have any common factors other than 1. Do you know how I could have divided in one step? If you said divide by 8, you were right. We could have done divided by 8 on that first step, and we would have got 3/4. And whether you're talking sports or academics or games, you often hear people say, who's number 1? Or I want to be number 1. Well, the number 1 in math is used all the time. So let's talk about who's number 1 in math. And see, any number divided by itself is 1. And this goes for variables too. And this is used all the time in math. So for example, if you had 9 slices of pizza, out of a 9 slice of pizza, then you had 1 whole pizza. And another way to think of that is 9 divided by 9 is 1. Or we could reduce it like this. 9 will go into itself one time. 9 will go into itself one time. So it's 1 over 1 or 1. But the same thing goes for variables. So like W over W. W represents any number, right? So let's say if W was 8, that could mean 8 over 8. Or if W was 4, that's 4 over 4. So either way, W is the common factor. So any number divided by itself is 1, but we could reduce it the same way. W will go into itself one time, and W will go into itself one time, so it reduces to 1 over 1 or just 1. So 1 is everywhere in math. It's used all the time. Some people call this guy number 1 in basketball, but a lot of people call this guy number 1. And that's for you to decide. But number 1 in math, there's really no debate. Everybody can be number 1, as long as you write them over themselves. 8 can be number 1. 8 over 8. Negative 4 can be 1. Negative 4 over negative 4. So everybody can be negative 1, even x over x. So are you number 1? Of course you are. Alright, to write variables in simplest form, expand out and cancel. I'm going to underline variables. So to write variables in simplest form, we're going to get rid of the exponents, in other words. So, for example, if we had w to the third power x over w x squared, we would expand this out as best we can. So we have 3 w's on top. W to the third means w times w times w times x. And on the bottom we have 1 w and then 2 x's, so times x times x. And remember, if you have something over itself, it's 1. Strive to be number 1. So w over w is 1. X over x is 1. And then w times w is what's left. See, nothing else cancels here. The w's and the x, there's nothing else to cancel. So we just have w to the second power over x. And that's our final answer. That's simplified all the way. Now sometimes, though, we'll have examples where nothing is left on top. But remember what I said. A number over itself is always 1. So for instance, let's say if we had, let's do another w. W to the second x, but this time over w to the third and x to the second. All right, let's expand that out. So on top we have w squared, which is w times x. And on the bottom we have 3w, so w times w times w, and 2 x's times x times x. So we can cancel these factors because w divided by w is 1, w divided by w is 1, x divided by x is 1. So it's tempting to want to write this and say, well, nothing's on top, so I have 0. But don't forget what this means. These are really 1's that we can write in. So it's really 1 times 1 times 1 is what's left on top. And 1 times 1 times 1 is 1. And then what's left on the bottom? A w and an x, so just wx is on bottom. And that's your final answer. So if everything cancels on the top, we're going to put a 1 on the top. So if the numerator numbers or variables all cancel, a 1 goes on top. And that's just understanding that anything over itself equals 1. And think about it too. If you put a 0 on top, 0 divided by anything is going to be 0. Alright, let's put it all together now. We'll do an example that has numbers and letters. So the directions would just say simplify, and we're going to simplify, let's do 22 x y to the third over 55 y x squared. Okay, I'm going to start off by, I'm just going to rewrite it. So 22 x, I'm just writing this as a multiplication of the factors. So times y times y times y over 55 times y times x times x. So I'm rewriting it without the exponents. And then I'm going to take care of the numbers first, and I'm asking, what is my common factor with 22 and 55? So what will go into both of those? So here's what I'm asking. My common factor of 11 will go, and I'm going to mark off the 22. It will go into 22 2 times. It will go into 55. 11 will go into 55 5 times. And I can keep asking that question. Do I have a common factor of 2 and 5? If I did, I would see how many times it would go into each of those, and I'd rewrite the number. But I'm done. 2 and 5 don't have any other common factors. Now check out my x's and y's. I have y's here that cancel, because y over y equals 1, and I have an x and an x that cancel. And I'm just going to rewrite what I'm left with. So I have a 2 for my number, and then I have my x and my y canceled, so I have 2 y's on top. So that's y squared. And then on the bottom, I have 5x. And I'm simplified all the way. And you can double check it at the end. Like, I have y's on top but no y's on the bottom. I have an x on the bottom and no x's on top. And my fraction is totally reduced. Alright, put your hands together for number 1. You did a great job today.